Go.
Hello, my dear students, and today we're going to do a quick lab where we're going to continue on writing the chemical names and the chemical formulas for some substances, only this time they're going to be substances that we create in a chemical reaction, because our next unit and our next topic is chemical reactions. So we're going to make some new compounds. We're going to start with two solutions, mix them together, and make a third compound in what's called a double displacement reaction, or a substitution reaction, or a precipitation reaction, and look at some new compounds. So let me get my lab coat and my safety glasses. And unlike the old days, where we would take a couple of compounds and a couple of test tubes and mix the test tubes together, and then we would spin them out in a centrifuge like this device up here, called a spinette centrifuge, and collect the precipitate. We don't waste a lot of equipment and a lot of chemicals to demonstrate the same principles now. We use something called microscale chemistry. And we're going to do our reactions on top of a reaction surface. It's a waterproof surface. It's a sheet protector. When we started this, we started doing it in microtiter plates. I'll show you one next time. And using very small volumes. Now we use even smaller volumes, and we've moved completely to this. So if you read the instructions, it says put a drop of each solution on. I'm going to wear my safety glasses. I'm going to be careful not to get any of these solutions on me. We're working with some toxic solutions like lead, strong bases like sodium hydroxide, potentially toxic materials like silver nitrate, although when I was a baby, when I was first born, they put silver nitrate in my eye. But I'm going to take this silver nitrate, and I'm sorry I put on my reading glasses. Let's see if I can get my safety glasses with side shields on it. It's always stored in a brown bottle because it is light sensitive. And I'm going to, in this row here that's silver nitrate, put a drop of silver nitrate in each of these squares, silver nitrate. And we'll learn about the solubility of different substances. Silver compounds and lead compounds are not known for being particularly soluble. So the next one is lead nitrate. I'm going to put a drop of lead nitrate, and because I'm handling lead and lead compounds, I'm going to wash my hands when I'm done with this lab. The next up and down row is copper sulfate. You can see the blue tint for the copper ions, the copper 2 ions, copper 2 sulfate. And the next one is magnesium sulfate, also known as Epsom salt. So I'm going to put a drop in each square where it's indicated. And the last one is the iron 3 chloride with its yellow, rusty tint, but it always looked rusty to me. I guess that's not truly the color of rust, but if you look at the bottle, most bottles of iron chloride get that on them. Even a glass bottle would have that on it. Next, I'm going to go across with what? Oh, the iron chloride also goes across in the first horizontal row. So let me put a second drop. And there are different ways of doing this. If it's a white precipitate, we want to see it on a black background. If it's a black precipitate or dark precipitate, we want to see it on a white background. So what we have is a very thick set of bars in the shape of an X here so that when we mix them together, we can compare. We'll be working with some other reaction grids later this year that have a diagonal, so 1/2 is white and 1/2 is covered with black ink. But I'm going to add the potassium iodide. I'm getting a big bubble, so I'm trying to get it out. And I made a bigger drop than I wanted there. See if I can pull some of that out. We'll just leave it like that. And next is sodium hydroxide, the base. Remember, anything with hydroxide is a base, OH minus ion, anion, polyatomic anion. So I'm going to put some big old drops on there. They bead up because of the cohesive and high surface tension of water. The next row calls for sodium carbonate. It's not sodium bicarbonate. This is truly sodium carbonate. And I'm going to add a drop of it to each reaction square. And when we're looking to see if a reaction has occurred, we're going to be looking for one of three things. Formation of a precipitate, formation of gas bubbles, evolution of the gas, or a change in color, usually indicating an oxidation reduction reaction. But what we'll be seeing mainly today is the formation of a precipitate, although we will see some bubbles and some gas being involved in a couple of these. It may just be heating up. I have a fingerprint or something on this one, and I have a line of the solution spreading out. That's very unusual, but I'm going to try and do these in order, but I may have to move down to that one to do it. So what I do now is I move my drops together and mix them with my toothpick. That's the silver nitrate and and iron chloride. This is the lead nitrate and the iron chloride, iron 3 chloride. Here's silver nitrate and potassium iodide together, forming a precipitate and a color change. Here is, this one's always interesting. You zoomed in on that. This one produces a brilliant canary yellow precipitate. The lead salts are beautiful. That's why they were used in paint so much. But I need to get this up here. It's getting too close to my other sample there. So I'm going to go ahead and do this one like that. Get it away. But of course, lead is toxic, so we no longer use these brilliant, beautiful lead pigments. Here's sodium hydroxide with silver nitrate. You may recognize that color as kind of a sepia brown. That's the color of some old photographs. They use silver salts. Watch the lead nitrate now. You'll see a pretty white precipitate. It may take a while to develop. We'll see it on the next one. Copper is turning a more intense blue, and if you look, it's kind of gelling up. It's the water is gotten thicker. Magnesium sulfate and sodium hydroxide should make magnesium hydroxide, also known as milk of magnesia. I probably need a higher concentration of magnesium than 10th molar to get a real obvious precipitate. And here's iron hydroxide. Wow, that beautiful rust color. Sodium carbonate with silver nitrate is going to make silver carbonate. And here should be a nice, pretty white precipitate with our lead. Some of those lead paints had beautiful, brilliant white pigments in them that, like I said, made great paints, but unfortunately, they're made toxic paints, so we don't use those pigments anymore. Here's copper sulfate with sodium carbonate. We're going to make copper carbonate and magnesium sulfate with sodium carbonate. It's going to make a bit of a solution there, and I've already mixed that one up, so I'll go over here, sodium phosphate with silver nitrate, lead nitrate with sodium phosphate. We're going to make lead phosphate. Should be a pretty and a white precipitate, as opposed to some of these that are off-white or yellow tinged. Here's copper with copper sulfate with sodium phosphate. I'm making copper phosphate. And here's mag sulfate with sodium phosphate. I'm making magnesium phosphate. And finally, the iron chloride with sodium phosphate. I'm making iron phosphate. And it'll be a much finer, paler precipitate than the other three. I'm going to write down the names of these and do the discussion in a little screencast later. But I want to show you, if we can zoom in on this, what happens when you let these dry. You can see clearly the precipitates, and some of them that didn't seem to have one actually do. This is magnesium hydroxide. You can see the circle here where the precipitate has formed, and magnesium hydroxide is insoluble, and it's also known as milk of magnesia, because that insoluble precipitate, when you shake it up, becomes a suspension throughout the liquid and looks like milk. And so that's where your milk of magnesia that you can buy comes from, and this is what it is. We just made milk of magnesia, or magnesium hydroxide. Magnesium is group 2, it's always +2. OH is a polyatomic ion that's always -1, so it's Mg, parenthetically, OH2. We don't need to add a Roman numeral because magnesium is always +2, so it will be magnesium hydroxide. And we will write those answers and do what we did before. Instead of looking at the compounds and me giving you test tubes full of them from our chemical stockroom, this time, at least the face-to-face students, will have made them themselves, and then we'll go and name them and practice our naming and writing of formulas some more. And I've also introduced a type of reaction that we're going to be studying. Later this week, we'll be studying some mathematical, quantitative aspects of chemical reactions, chemical solutions, chemical quantities, and then we will move into the different types of reactions. So until next time, stay safe, and I will see you in the next video. Goodbye now.